Crypto News. I'm Kurt, and I wanted to talk about the EOS bug that just happened, and some of the FUD and some of the fear. And I think people kind of don't really understand it, and there's a lot of people that are kind of scared. So I wanted to sort of describe what actually happened from a coding perspective, but I want to keep it high level so that we don't get too into the coding details, but we can just understand what happened and why, and also share my opinion on why I think it happened and what it really means. So what happened was called a buffer overflow. It's a buffer overflow problem, like a bug, could be considered a bug, or just a vulnerability in the program that they wrote. Or a buffer overflow attack. Essentially what a buffer overflow is in programming, you need to write some data to memory somewhere. So EOS uses C++, and in C++ it has this feature where you as the developer have to care about how you allocate memory and deallocate memory, and how you manage the memory. A lot of other programming languages, like these newer ones like JavaScript and Java, they manage the memory for you. So in a way, C++ is a little bit more powerful because you have more control, but at the same time, you're opened up to more vulnerabilities. So what happened was a Chinese company came out and figured out that EOS has a buffer overflow problem. What that really means is there's a part in the program where if you upload code to the EOS blockchain, it can run on this blockchain, and if somebody injects a little bit of code that goes outside of this buffer because they didn't really check in the EOS code base before, now it's fixed totally, but before somebody figured out that if you just add in a little bit of extra data to that array, that EOS doesn't block you from doing that. And traditionally in a program, it has a check for this kind of buffer overflow, like an assert, or now they have a new assert method that they implemented that actually fixes it. And I want to go into more detail about what that actually was, but I kind of wanted to break it down into an analogy so people can sort of understand what happened. So imagine that somebody wanted to remodel your kitchen, for example, okay? And they come in to like paint and restructure it. So this is like the development team, of EOS would be like these contractors that come in to build out and remodel this kitchen, right? So they repaint it, they do a really good job, it's pretty sweet in everything they do, but they're still sort of in construction, so they leave this tape on some parts of, a cabinet or somewhere, right? And then this Chinese company that found the bug, they're sort of like the auditor, or somebody will come in and check out the house to make sure it's okay for when the owners move into the house. And what happened was these auditors came in to look at these contractors' work, and they're kind of like, hey, good job, but you left this tape here where this paint is. And keep in mind, the house isn't supposed to actually be ready. Not that it's an excuse, it's just I'm trying to help you understand what actually happened here. And so the EOS developers, or the contractors, like left this tape there, even though they're still working on it. So, perhaps later they had a checklist where they're like, I'm going to pull that tape out or something. So they can get fully prepared for the owners to move into this house. They have to, maybe take a bucket out of the kitchen and maybe mop up the floor again because maybe there's a speck of, dust or paint, take the tape off, do some extra checks. There's a lot of like, after you're done with the remodeling and the repainting and all of that, there are some little, trade tools that would kind of be left around the site, right? And so really what's happening here is that this company, when they did the audit, they pushed it out to the production environment. And what was checking for these buffer overflow attacks was these assert methods that basically say, hey, did somebody throw something into this code, or write something, or give a piece of data that was supposed to go into this array that could be garbage, but could potentially be dangerous actually. And so these cert methods would work in debug mode, but they wouldn't work in production. And so they didn't really have anything covering their ass in production, which to me is, it, some people might look at it as an amateur mistake, but it also could be seen as one of those things. Is like you come into this kitchen and you see that there's tape. It's like, why the fuck is this tape still there? Well, the developer might be like, well, I'm gonna rip the tape off at the last moment. And I don't really know if that was what they were trying to do in EOS, but it's definitely one of those things where you're supposed to add these sort of checks for this kind of stuff. And they had the checks there, they just only had them in development. So I'm not exactly sure why they wouldn't have them there for production. It could have just been an amateur mistake. And I'm not saying those guys are amateurs. It's just like there's a lot of shit you have to care about when you're developing these kind of platforms. And, frankly, a lot of software goes out with bugs in it. It's not like, there's no such thing as bug-free software in the world. First of all, Facebook is still fixing bugs, and Facebook has a bug bounty program. So, why is leaving the tape there so bad? Well, this could potentially be a huge problem. So let's imagine that this tape is highly flammable or something, right? And so even though it's an amateur mistake, it could have been potentially responsible for burning the house down. And I don't want to create more fear, but what this Chinese development and security company figured out was that because you're allowed to write extra data to these buffers, you could potentially put malicious code inside of these buffers, and you start to have more control over what kind of programs and data goes into this extra memory. And I'm not 100% sure how vulnerable that would have been, but they do claim that you could place viruses and other things on there that could propagate to other systems, and you could do so through these kind of buffer overflow attacks. And so that's why it was so dangerous. And generally the process for, my guess is that it was an honest mistake, but it doesn't matter, because even if a mistake leads to a vulnerability that could be a potentially big problem, it doesn't matter if it's an honest mistake or not, truly. And so the way that these things are normally, this is a pretty common thing in software where a company will come out and audit and check the security of something, and they find something and they report it. But, so on the EOS end of those developers, I feel like they have some responsibility for fucking up like that, and, having a vulnerability open in the public like that. But, there are good sides and bad sides. What happened with Dan Larimer was he blasted out to the community that I'm going to give you $10,000 if you find any other issues like this. And so it's kind of like the last hour, which makes me a little bit worried. I kind of wish that they would push back a little bit. But, there could be other bugs that aren't detrimental to the entire system, but I wouldn't risk it. I would start bringing in more of these security auditing companies and even paying them up front. Like a bounty right now is not good enough. We need probably a few security auditing companies that come in at a fee and that know what the fuck they're doing and come in there and make sure that this thing is secure, because a lot of people have a lot of money riding on this. I think bounties are, maybe those would have been cool a month ago, but right now it's almost production time. The shit's about to go live. So we don't want somebody potentially compromising the system. So, but aside from that, the way that we normally, or that companies normally audit this stuff, like white hat hacking, for example, where you might find a vulnerability in the server, and rather than exploiting it, like, that Chinese company could have very well just been like, look, we could just steal all the money out of everybody's wallet, so let's just chill out, not let anybody know about it, and then, unleash this bad boy and fill up our wallets and see you later, and that's more of like a black hat hacker's incentive. But the way that they normally do it is they will release it to the company first. If that company has a problem, they'll say, hey, here's a problem. And they reported it to Dan Larimer, and it was fixed immediately, right? But then the thing that sort of rubs me a little bit the wrong way is that they publicized it. And I get it, like that's how they find other customers. Like I guarantee that they might even find a job with EOS. If I was EOS, I would probably respond to them to say, here's $50K, go and do some more work on this stuff. And that's honestly how a lot of hackers get jobs. They just go and hack stuff and reveal it to the company, and the company says, hey, you're pretty smart, why don't you come work for us? It's a really common thing. It's almost like a job application for some hackers. And so the thing that rubbed me a little bit wrong about it was that they they gave it to the EOS team and then they publicized it everywhere, which is kind of good for them, but I don't know how good that might be for the entire ecosystem, especially considering how scared people were. I mean, the fix for it wasn't like a major complex architectural problem. It was probably a few lines of code, and the fix was rolled out pretty quickly. Also, I think it kind of gives a feeling that the EOS team is amateurish, which sucks because I don't think they deserve that. They're pretty competent guys and pretty smart. But that they did this bug bounty program, it could be an early sign of something that could be a larger potential problem. So I don't want to be too biased here. I am a big believer in EOS for sure, as you know, but I don't really have like a specific pony in the race. Like I'm not gonna benefit a ton off of EOS. Like I pretty am distributed across technologies here where, I want the whole ecosystem to thrive mostly because I think we have the most to profit if the entire ecosystem does thrive. So I still like Bitcoin. A lot of people that are into alts, they don't love Bitcoin. But yeah, the bug reporting was a little bit overboard. It was a little too like, hey guys, look how fancy I am that I found this bug and let me use this opportunity to advertise my own company. So that kind of rubbed me the wrong way. But overall, I think that this is not a big deal. But that being said, that simple problems like this could still exist for whatever reason, and that they are vulnerabilities of some kind, and they're pretty amateur ones. Like buffer overflow is a thing that has existed in computer programming since the array existed, or since memory allocation in programming languages has existed, which is probably like 40 years or more. I don't really know how long, but so this is something that I feel like probably shouldn't have been a problem and might cause, but there's larger issues with Vitalik coming in and trying to school them and show them how to write better scaling and better algorithms and better consensus models. I think that they're dealing with a complex environment and it's sort of hard for them and it's a little bit embarrassing. But my overall view on this right now is that it's not that big of a deal. They already have it fixed, by the way. It's fixed. That is no longer an issue. And it's one of the main ones. And then just another couple of points on the bugs is that I have seen Dan Larimer say that a lot of the bugs are actually related to third-party libraries and stuff that isn't really their own custom code. And these problems just exist, but they're not major vulnerabilities. They're really problems with you have to mix and match a lot of libraries when you build a system like this. And there are a lot of dependencies and vulnerabilities in different versions and stuff like that. And it's a complex environment. Every developer has to deal with this. It's just that in this situation, it's a bigger deal. Nobody would give a fuck about Facebook having some vulnerability. I mean, maybe one like this buffer overflow is probably a big problem for Facebook too. But nobody really cares if you find a bug in Facebook that much, unless it exposes everybody's private security or something. There's always bugs and fixes that happen in Facebook. But the reason why it's a big deal here is because now we're dealing with a lot of money. Like, look at how much money has been stolen out of Ethereum smart contracts based on, simple errors. I mean, there's a lot of lines of code. The more lines of code you have, the more vulnerable you are, the more problems there could probably be. But my overall view is that this is a hiccup that I'm glad happened, because now they're actively seeking people to find bugs, and hopefully that will harden the system a little bit more. And maybe if this didn't happen, somebody would have taken the whole system down or something. Who knows? Anyways, that's all I got for you. Thanks for watching.